An imaginary number is the square root of a negative number. Imaginary numbers can be written in the form bi, where b is a real number and I is an imaginary number. The square of an imaginary number is the original negative number. So anytime you're given something that has a negative square root, in the olden days, your teachers used to tell you that that couldn't happen, that you couldn't have a negative radical. So let's if I had negative 16, the square root of negative 16. Well, the first thing you're going to do is you're going to rewrite this as the square root of 16 and then put an I on the outside. That I just means that this is going to be an imaginary number. So my answer would be just 4I. We don't change how we simplify radicals down. It's just if there's a negative inside, we just put an I on the outside, just stating that it's an imaginary number. Okay? So if I had something like 2 times the square root of negative 4, well, I would rewrite that as 2, and instead of putting the I on the outside, I always just put it behind the whole number. So 2I square root of 4, well, the square root of 4 is 2, so this would be 2I and then times 2, so really that would just be 4I for my answer. Okay? Really important thing in math is that I squared is equal to negative 1. That is so important. Make sure you put this in your notes. I squared is equal to negative 1. Okay? And the reason is, if you had, if you take a look up here, the square root of negative 1 squared, well, when you square that, you get the square takes rid of the square root, so negative 1 is really equal to I squared. And I squared is equal to negative 1. Big piece of information in this section, so you have to remember that. All right, so let's simplify a few. If I gave you something like 5, the square root of negative 21, I would just rewrite this as 5. My marker's not working here. 5I square root of 121. The negative inside makes this an I. And then that would just be 5I, and then square root of 121 is 11, so this would just be 55I. So nothing changes except when you have that negative inside a radical. It just means that it's going to be an imaginary number. If I had the square root of negative 12, I'm going to rewrite this, and this is where, simplifying radicals, I'm just going to write this as 12I, but then I'm going to simplify this. I know that the square root of 12 can break down to the square root of 3 times the square root of 4. Square root of 4 is 2, so my answer is going to be 2 square root of 3I. I would usually write the I behind the whole number, so I would write it this way, 2I squared root of 3, but this is not incorrect. However, it would be incorrect if you wrote it this way, and a lot of kids do this. They leave the I underneath the radical symbol. That is not correct. So you put your I underneath the radical symbol, it's not right. It's on the outside. And one more. If I had 2 square root of negative 36, right away, the first thing I do is I look at this, and I'm going to just rewrite it as 2I square root of 36. And then the square root of 36 is 6, so this would be 2I times 6, and that would just give me 12I. So simplifying radicals with negatives inside, fairly easy to do. Now we're going to get into this. These are called imaginary numbers. Okay, so now we're going to talk about complex numbers. What is a complex number? In mathematics, a complex number is a number that can be expressed in the form a plus bi, where a and b are real numbers, and I is a symbol called the imaginary unit, and satisfying the equation I squared equals negative 1. Because no real number satisfies this equation, I was called an imaginary number. For the complex number a plus bi, a is called the real part, and b is called the imaginary part. Okay. So now, this week, what we're going to be doing is we're going to be adding, subtracting, multiplying, and dividing complex numbers. So, for example, you might get something like this. You might get a problem that is 2 plus 3a. I'm sorry, I don't know why I put an a in there. 2 plus 3i plus 4 plus 2i. Well, when you add complex numbers, you add just like you normally would an I. The I just stands for a variable. It's just a variable. So I'd add the 2 and the 4 together. So that would give me 6 plus, and then the 3i plus the 2i would give me 5i. So you'd add it just like it's a regular variable. Now, when the I is not to the first power, it becomes a little bit more complicated because you always have to, you can't have an I with more than the first power to in the answer. So you can never have, for example, if I gave you something like, let's say I said, okay, let's do this problem. And, we'd use distributive property. So 2i times 5, you just pretend this is a regular variable. So that would give me 10i plus, and then I would multiply the 2i times 2i, which would give me 4i squared. Now, if you stopped here, you would get it wrong. You cannot have any I that is more than the first power. Well, I have a second power here. Okay, you can see it. It's right there. It's I squared. Well, remember, we said that I squared is equal to -1. So in place of I squared, I put -1 here. So my answer would be 10i plus 4 times -1. So really, it would be 10i minus 4. So that's a huge thing you need to put in your notes. You can never have an answer in a problem like this with complex numbers where I is more than the first power. You can't have an I squared, you can't have an I to the third, you can't have an I to the fourth, you can't have an I to the fifth. That is not simplified down then. All right, adding and subtracting complex numbers is similar to adding and subtracting variable expressions with like terms. Simply combine the real parts and combine the imaginary parts. The set of complex numbers has all the properties of the set of real numbers. So you can use commutative, associative, distributive property to simplify complex numbers. So it's basically like I is just like a normal variable unless it's not to the first power, and then you have to deal with it. Okay, so for example, if I had a problem like this, I'm just looking at this problem, and I'm saying to myself, okay, I'm just going to add the 4 and the -6 together, so that gives me -2. The 2i and I'm going to change that minus sign and make that a -7i. So the 2i plus the -7i really gives me plus -5i. I'm done. My I is to the first power. I don't have to simplify any farther down. Here, if I have a subtraction, now this is where it gets a little, some kids, they really mess up here with that minus sign in there. Usually, I always put a 1 in front of here, and then that minus sign I change to positive, and I change that to negative. So I'm going to multiply through. It's going to be the distributive property, but I'm also going to change this so I don't mess up. I'm going to change this so I don't mess up. So really, I have 5 plus -2i plus, and the -1 times -2, that gives me 2 plus -1 times -3i. Well, that gives me positive 3i. Okay, I knew that subtraction in between the two parentheses usually causes some problems. So now I'm just going to add the 5 and 7, or 5 and 2 together to get 7, plus -2i plus 3i, that gives me 1i. Simplify down. That's what we're working on this week. We're going to be simplifying simplifying complex numbers down. Add or subtract, write the result in the form a plus bi. Again, this, I've got 4 plus 4, so that's just going to give me 8 plus, and then 3i minus 3i, well, that's just 0. So if I simplify this down, my answer is just 8. I could put plus 0i if I wanted to. I don't have to. I mean, 0i is just 0. You can multiply complex numbers by using the distributive property and treating the imaginary parts as like terms. Simplify by using the fact I squared equals -1. So remember, you can never leave I squared or I to the third or I to the fourth. So in this problem, I'm going to use distributive property. I'm going to multiply through. Okay, so if I multiply through here, I'm going to change the subtraction first because I don't like that. -2i times 2, well, that gives me -4i. Plus -2i times -4i, well, that gives me 8i squared. Can't have an I squared in there. I squared is equal to -1, so I'm just going to put that as -1. 8 times -1 is -8. So I'm left with -4i plus -8. Done. That's it. Multiply, write your results in a plus bi form. Well, this is just multiplication. It's just negative 5i times 6i. Well, negative 5 times 6, that's negative 30. Oops, I got to turn my marker on again. So I've got negative 30i squared. Well, I squared is negative 1, so negative 1 times negative 30 is 30. That is simplified as far as it can go. Negative 5i times 6i is equal to 30. That is it. Another distributive property here, just multiply through here. 2i times 3, 6i minus 2i times 5i gives me 10i squared. I'm going to change this because I don't like that. So that's negative 10. But then I'm going to, my I squared is negative 1, so negative 10 times negative 1 is 10. So my answer is 6i plus 10. I love these problems. The imaginary unit I can be raised to higher powers as shown below. I to the first is I to the second is negative 1, I to the third is negative I to the fourth is positive 1. I to the fifth is I to the sixth is negative 1. Can you see a pattern here? It just goes, I, negative 1, negative I, 1, I, negative 1, I, 1, I, negative 1, negative I, 1. It's a pattern. Every 4, it's going to change. And the reason, and I'll try to explain it as best as I can. I'm just going to get rid of this problem here. Okay. So we have I squared, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh. Okay, so let's just see what we get here. So I is just I, right? We know what I squared is. They already told us. They told us I squared is negative 1. So what is really I to the third? I to the third is really I times I times I, or I squared times I. Well, we know I squared is negative 1, so that's negative 1 times I, which would give us negative I. I to the fourth, well, I could rewrite I to the fourth as I squared times I squared, which is negative 1 times negative 1, which is 1. So I to the fourth is 1. And then you'll see it's going to jump back. Every 4 that you go out, now I to the fifth better be I. Well, I can check it out. I to the fifth, I can write as I squared times I squared times I. Well, I squared times I squared is negative 1 times negative 1 times I, which is 1 I, which is just I. So yes, so I to the sixth would be negative 1. I to the seventh would be negative I. And it just keeps, and then, it just keeps going back and forth. Now, this is where, if I asked you, what is I to the 72nd? Now you're going to have to do a lot of thinking. Or there's a really easy rule to follow, okay? And that rule is, if you have a bigger number here, all you really have to do is divide and see what the remainder, divide by 4 and see what the remainder is, okay? So if I divided by 4 and the remainder is 0, okay, I just divide the power by 4, the remainder is 0, my answer is just 1, or I, or you can work that out. So for example, if it's 0, if the remainder is 0, my answer, I'm sorry, where's my marker here? Answer is I. It's just I. So this is a remainder of 0. Oh man, my marker's not working here. Okay, so if I have a remainder of 0, my answer is I. If I have a remainder 1, I gotta look at this again. I'm just all right. I know this rule. Let me go back. I gotta erase this. Nope, that doesn't erase. Okay. All right, so I gotta do this in my head so I don't give you guys the wrong answer here. So we've got I squared, I to the third, I to the fourth. So this is just I, -1, 3, that's I squared times I, so that's -1I, or just -I. And 4 would just be 1. Okay. So I'm just looking at this, and then I'm just gonna I to the 5th would be I to the 6th would be -1, I to the 7th would be -I, and I to the 8th would be 1. So now if I divide it by 4, okay, I'd have a remainder of 1 here. So remainder of 1 would give us I for an answer. Remainder of 2 would give us -1. Remainder of 3 would give us -I. Remainder of 4 would give us 1. So if I asked you what is, let's say I said, what is I to the 40th? Okay, I just take 40, I divide by 4. Now let's do one that we can check our answers on. Okay, let's do I to the 10th. Okay, I to the 10th. If I divide 10 by 4, I get 2 goes into it, but that I don't care about that. I just care about the remainder. So the remainder is 2, right? So I would say that my answer is -1. Well, let's finish this off. We did I to the 2nd, I to the 3rd, I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th, and remember, now it just starts repeating again. I to the 9th would be I to the 10th would, that's an I to the 10th would be negative, did I do this right? -1. So my remainder of 2 should be -1. So it does work out. So whenever you have a power that's way up there, and you will get a question like that on your assessment, just divide by 4. Whatever the remainder is, all you have to do is look at this little chart right here. It should just be a 1. Okay. All right. So here I have 1/2 I to the 7th. Well, I to the 7th, we already said, let's go back one, we already said that I to the 7th is -I. So my answer here is just going to be 1/2 -I. That would be simplified down. Okay. Now you can also simplify. When you simplify an imaginary number, you cannot have an I in the denominator. Okay. Well, hopefully in, let's say, Algebra 1, you learn that you can get numbers out. Like, for example, even fractions. Let's say I had a fraction, and I said I had 3 halves, and I want to get that 2 out of there. I could multiply top and bottom by 2, right? So that would give me 6/4. I no longer have a 2 in the bottom. Well, same thing here. I'm going to multiply top and bottom by I. Because when you multiply the top and bottom by the exact same thing, you're really multiplying by 1. So here, if I multiply the top by I, I'd end up with 3I plus 10I squared. Well, we can't have an I squared in there, so I would rewrite that top as 3I plus -10. And then on the bottom, if I multiply by I, I'd end up with 5I squared. I squared is -1, so that would be -5 on the bottom. This would be simplified. I no longer have an I in the denominator. And the reason I multiplied top and bottom by I is to get rid of that I in the denominator. All right. Hopefully we see you guys at Monday's main lesson. You guys have a great weekend. Bye.